Welcome to your introductory lesson on circles. Now, if you could, please look to the center of your screen. You are getting sleepy. Your eyes are getting heavy. I want you to think now, every time you hear the word circle in class tomorrow, I want you to cluck like a chicken. All right, for the first part of our lesson, you're just going to listen. Please do not feel the need to write anything. Just going to observe what's being shown to you. Let's begin here with this question. What do you create when you plot points that are all the same distance from one point? So like this. We are plotting points and they are all the same distance from that one point there. Hopefully you're thinking, well, if I keep going, I will have a circle. And that is at the heart of what a circle is, the definition of a circle. We have all these points that are all the same distance from this point right here. How many of these points are there on a circle? Well, I hope you're thinking in infinite. There are infinite points on a circle. You could draw infinite points around this here, along this line. And what part of the circle is the distance we used to plot the points? So when we went from here to here, and there's a distance here, and there's a distance here, and a distance here, what is that called? Well, in a circle, that distance from here, center to the circle, is called the radius. All right, so you're probably familiar with circles, and two main things you learn about circles early on in your math career are circle area and perimeter. And perimeter of a circle is also known as the circumference. So here are the formulas. For area of a circle, we have pi times radius squared. And for circumference of a circle, we have 2 times pi times radius. Or sometimes you'll see this as pi times diameter. But where does pi come from? Where does this number that we know is 3.14, where does it come from? Why do we have it in these formulas? Let's take a look. Where does pi come from? Pi comes from the idea of taking a circle, measuring its circumference, and here the circumference or perimeter is 40.5, and dividing it by the diameter. And here the diameter is 12.89. I've already entered these numbers into a Google calculator. So 40.5 was the circumference divided by the diameter. What do we get when we equal that? Oh, notice 3.14. And you may know this as pi, 3.14, and then it keeps going forever. So pi comes from measuring any circle and dividing circumference by diameter. Well, let's try another one here. Here's another circle. The circumference is 12.57 and the diameter is 4. Let's see what we get. 12.57 divided by 4. Oh, 3.14 again. All right, and this last one, 19.48 and 6.2. 19.48 divided by 6.2. Are those the right numbers? Yeah. And 3.14 again. So that's where pi came from. A bunch of people were investigating circles. They measured circumference, diameter, and no matter what circle they used, they got the same number, 3.14. So circumference divided by diameter is 3.14, or pi. That works in any circle. For example, this bike wheel, circumference divided by diameter will give us pi. Or this sumo ring, for all you sumo fans out there, which is all of you, of course, circumference divided by diameter will give you 3.14, or pi. Or this basketball, you can measure the circumference divided by the diameter and you will get 3.14, or pi. Or this ancient contraption known as an iPod, you can measure circumference and diameter of the wheel here and you will get pi. And this thing, top of a can, circumference by diameter, pi. I think you get the point. That's where pi comes from. It's not a made-up number. It's not mysterious. That's where it comes from. Planet Earth, same thing, pi. All right, time to take some notes. I provided you with a notes page. Let's use that now to take our notes. So first of all, the definition of a circle. The circle is the set of all points in a plane, that basically means it's two-dimensional or flat, that are equidistant, which means the same distance from a fixed point, which is the center. So again, the set of all points, all these points that are equidistant, this is the equidistant part here, the equal distance from a fixed point, which is the center. Some vocabulary you should know. This is called the center. This orange line that has appeared is the diameter. It is the distance across the circle through the center. And this green one that has appeared, we already mentioned, is the radius. It's from the center to any point on the circle. Label the diagram on your notes page. Somehow maybe drop arrows to the appropriate parts. Okay, those are words you're definitely familiar with. Let's look at some that maybe you know, maybe you don't. First of all, this part here, any portion of the outside of the circle is called an arc. When you shade in like a pie piece or a pizza slice, that means from the center to the outside like that, that is called a sector. Any segment within a circle that goes from one point to another point is called a chord. The diameter here is also a chord. Diameter is a chord that passes through the center. This is a chord that does not pass through the center. Then we have lines like this. Notice this is different. They have arrows now. That means they go forever. This one does not go forever, the chord, but this purple one does. That one there is called a secant. It passes through the circle at 1 and 2 points. And then we have this orange line. It also goes forever in both directions. It touches the circle only at 1 point. That is called a tangent line. And finally, anytime you shade any slice of the circle, not a slice that necessarily goes to the center like a sector did, this kind of area or any part of the circle is called a segment. So make sure you see the difference between a sector and a segment. So please label those appropriately on your diagram. Okay, next, there are different kinds of arcs. A minor arc is an arc that is less than 180 degrees. So in other words, it goes less than halfway around the circle. That's a minor arc. A major arc is greater than 180 degrees. So it goes more than halfway around the circle. And a semicircle then is an arc that's exactly 180 degrees, which means halfway around the circle. Here's a diagram that you should label as well on yours. You have blanks here, fill them in. So again, sectors were parts of a like pizza slices in a circle. This is called a major sector when it's bigger than 180, and a minor sector when it's less than 180 degrees. Over here, it shows the arcs again. So here's a minor arc, less than 180 degrees, major arc, and then segments, minor segment and major segment. So I hope that all makes sense, and that's all the main words you should know for circles at this point. We'll be using them a lot in the work that we do. So let's see if you know your parts. Try the questions you see on your page using these two diagrams, and let's see if you can answer them correctly. All right, the main part of today's lesson, after getting all those circle words into your brain, is to figure out how to calculate the length of a chord. So our goal is to, if we have a circle and we've drawn a chord here, and maybe you've connected to the chord using 2 radii, how long is that chord? There's a way to figure it out. We're going to look at it now. Okay, so let's say, this is not on your page, just take a look at this for a moment. Let's say you start with a chord, so here's a chord, and somebody says, how long is it? Well, it might be helpful to first connect the chord, the endpoints of the chord to the center. So basically we've drawn radii here, one radius and another one. So now I want you to answer, what kind of triangle have you created here? Okay, well I hope you remember your triangle names or classifications. This is an isosceles triangle. An isosceles triangle is one that has 2 sides that are the same length. And in this one, since this is a radius and this is a radius, those are the same length. So this must be an isosceles triangle. All right, when we're finding the length of a chord, it's also helpful to continue by drawing a segment from the center to the midpoint of the chord. So we basically cut this chord in half, and we've drawn this segment here. Now, question, what kind of triangles have we created here? What kind of triangles are these two? Well, hopefully you answered right triangles, because if you go in an isosceles triangle and you cut it in half, right here, this angle right here and this angle right here will be 90-degree angles. We have created 2 90-degree triangles, and that's going to be important in how we calculate a chord's length. So let's take a look at this sample on your page. We have this circle, we have a chord AB, we have this central angle of 60 degrees, and we see that the radius is 5 centimeters long. So that would be 5 centimeters as well. And it says find the length of chord AB. So how long is this? We have all the information we need. Let's take a look how we can do this. First, as I mentioned, it might be helpful to bisect your triangle or bisect the central angle like this. So you draw a segment through there that cuts it in half. And as we mentioned, when you have this isosceles triangle, now these two triangles are actually congruent right triangles. So I've taken and added a diagram here of this triangle right here. So notice that when we cut this angle in half, it was originally 60. So now this part must be 30 and this part must be 30. Both of these halves are 30 degrees. So there's our 30 degrees. Here's the radius. Here's that 5 centimeter radius. And now I've labeled this part x. And again, it's important to note that this angle here is a right angle. So here's your right angle right here. So we've created a right triangle, and there's a congruent or equal right triangle right here. Let's take a look at this right triangle. We're going to use something maybe you have used before or not. Some of you may be familiar with trigonometry, and some of you may not be. We have not done that unit yet, but maybe you've done it in the past in some other program. So we're going to use some trigonometry here. You may not be familiar with this, so don't be scared off by what you see. Let's just take a look. I'm going to show you this now, and later when we learn trigonometry in detail, you'll learn more about it. Basically, when you have a right triangle, and you have an angle here, and you look across that angle, this is called the opposite side. And then this side here in any right triangle is called a hypotenuse. It's the side that's across from the right angle. It's also the side that's diagonal. So when you sine, this is read as sine, not sin. Sine is a ratio we can create between the opposite side and the hypotenuse. And we can always write it like this. Sine of this angle that we see here, sine of 30 degrees, equals that opposite side, that side across from there, divided by the hypotenuse. So it's always going to be written this way when we have this angle, this side, and this hypotenuse. So we have that. Sine of 30 degrees is just a number. You punch this in your calculator and you get a number. So let's take a look how we do this. But first, we're going to be solving for x, right? So if we solve for x here, we're going to multiply this side by 5 so that the 5's cancel and multiply this side by 5. So really, we'll change the equation to this. Hope you see that and it makes sense. All right, we multiplied by 5. Now let's look at what sine 30. You can use your Google calculator as well. But I just did search for calculator. I have this calculator open up in Google. And you'll notice it has sine, it has this other thing here, which is cosine, and this is tangent. When we learn trigonometry later, you'll use all three. Today, we're just going to focus on sine, all right? And what did we have there? We had sine of 30. So I'm going to punch that in. Sine and 30. And I want you to note that, oh wait, that's not right. That this right here, right now is in radians. I'm going to click this here and make sure we see DEG, which is degrees, because we're using 30 degrees. So make sure you do that if you're using the Google calculator. Degrees, all right? I'm going to do sine of 30 equals. Gives me this value. And then we have to do sine 30 times 5. So I'm going to multiply that by 5. And I actually get 2.5. So again, x equals 5 times sine of 30. And sine of 30 was just 0.5. And that equals 2.5. 5 times 0.5 is 2.5. All right, so that means x is 2.5. Here you may notice that AB, the chord, which is the original goal, is actually x here and x again. So it's going to be double x, right? This part and this part. So AB is 2x. That means AB is 2 times 2.5. That means AB is 5. All right, don't get the idea in your head that this 5 here will always be equal to what we had here, which was the 5. Anyway, this is all coincidental that this is 5 and 5 again, but there's 5 centimeters for that. So I hope that makes sense and you're not too worried about using trigonometry. We just learned how to use sine. It's just punching on your calculator. Now I want you to try this one and let's see if you can find the length of chord xy. Follow the same steps. Use your Google calculator if you need to find the sine value, and let's see what you get. Hopefully you were able to break up the triangle like this. That 30 degrees becomes 15 degrees. This is still 6. Here's a. Sine of 15 equals a over 6. Multiply by 6. Got this number. Double it. to get the full length of the chord and